Statistics is the science of data. The whole point of statistics is we gather data on things and try to learn about the world around us. So suppose we've recorded the mileage on 100 cars, or the productivity of 200 wheat fields, or the weights of 300 cancer patients, or the household incomes of 500 customers. So we have this long list of data, long list of numbers. How do we make sense of that? Well, the first thing we want to do is try to boil those numbers down to just a few numbers to try to describe what we've got. What we want to do is compute summary statistics, a few numbers that tell me something about the distribution of all of them. First thing we'll look at are the mean, the median, and the mode. These numbers tell us something about where the center of the distribution is. They are measures of center. The mean is... There we go. The mean is the average. We've done that before. We know what an average is all about. Here's a simple example. Suppose I survey 5 people and I say, how many pets do you have? The first person says, I have 1 dog. The second person says, pets. The third person says, I have 2 cats. The fourth person says, I have 3 dogs. And the fifth person says, I have 1 goldfish. So my data is 1, 0, 2, 3, and 1. So if I want to take the average of that, what do? I add them up. I divide by 5. 1 plus 0 plus 2 plus 3 plus 1 is 7. 7 divided by 5 is 1.4. These people have an average of 1.4 pets. We can do this in Excel. So let's, here we go. We've got pets. Our data is 1 and 0, and what was that again? 2 and 3 and 1. So if I want to now compute the average, what I do is I go into Excel and I do average is the command. I give it the range of cells. So in this case, that's A2 through A6. Press enter, and lo and behold, Excel can compute it just as well as I could. All right, so there's the mean and the average. What else can we do? The mode is something we might use. In this case, the mode is the most frequently occurring number. That's the number that occurs more time than any other numbers. In this case, we had 2 people who had 1 pet, the first person and the last person. No other numbers repeated at all, so the mode is 1. So if I go to Excel and I want to compute the mode, equals MODE, I give it the same range of cells, A2 through A6. And I go, there it is, the mode is 1. If none of the numbers ever repeat, we don't have a mode. Let's talk about the median. The median is the middle. So if I want to do this, the first thing I do is I put the list of numbers in order, say from smallest to biggest. So my numbers in order are 0, 1, 1, 2, 3. And then I choose the middle number on the list, in this case 1. Now in this case I got an odd number, so there is 1 middle number. If there was an even number of numbers, then you take the 2 middle numbers and you average them. In this case, the median is 1 pet. Excel knows all about that. We do median, A2 through A6, 6, and yep, still 1 pet. All right, so that's the mean, the median, and the mode. These are 3 ways to measure the center of a distribution. What else can we do? Well, if I'm not as interested in the center, but now how are other things laid out? I can talk about quartiles. A quartile is, so if I take the first quartile, that would be a number that has a quarter of the numbers below it and 3/4 of the numbers above it. So like the median, first I put things in order, but now rather than choosing the middle number so that half the numbers are below it and half of them are above it, instead I choose a number that has 1/4 of the numbers below it and 1/4 of the numbers above it. So in this case I choose 1. It's got 0 below it, 1 number, 3 numbers, 1, 2, and 3 above it, and so the first quartile is 1. The second quartile would be the median, because that's got 2/4 or half of the numbers above, half below. If I want the third quartile, well, that number is going to have 3/4 of the numbers below it and 1/4 of the numbers above it. So that's a 2. The 2 has 3 numbers below it, 0, 1, and 1. It has 1 number above it. There's the 3. So the 2 is the third quartile. We can do this in Excel. So we call this Q1. So I do quartile. And I give it the range of numbers, A2 through A6. And I want the first quartile. And there it is, 1. If I want the third quartile, I do quartile, and oops, got to type an equal sign if I wanted to do math. Quartile, A2 through A6, third quartile, and yep, there's 2. So that's quartiles. That gives me a value that has 1/4 of the numbers below it, 3/4 above it, or 3/4 below it and 1/4 above it. So that's what we've got. What's the next thing I can do? Percentiles. Now this is a more generalization of that. So now I've got a number that has a certain percent below it and a certain percent above it. For instance, the 10th percentile is the number that has 10% of the numbers below it and 90% of the numbers above it. The 60th percentile has 60% of the numbers below it and 40% of the numbers above it. So in this case, well, we've talked about quartiles. The first quartile is the 25th percentile. The median is the 50th percentile because 50% of the numbers are below it. And then the third quartile, well, that has 3/4 of the numbers below it, so that's the 75th percentile. And I can do percentiles in here. So if I want to do the 10th well, I guess let's do the 25th percentile. That's going to be the same as Q1, so I type percentile. I give it the range of numbers, A2 through A6. I tell it I want the 0.26 or so 0.25, the 25th percentile, which is the Q1, and hey, it's 1 again. Not so useful on a very short list of numbers like this. Really, really handy on a big giant list of 500 numbers, which we will be dealing with pretty soon. All right, let's see what's next. The next thing I can do is I can calculate numbers that tell me how spread out the numbers are. Okay, so the average is 100. Lovely, fantastic. Are most of the numbers close to 100? Or are, some of them very far above and some of them very far below? Just by telling you the average, you don't learn anything about whether they're close or far from 100. It just means that they averaged out to 100. So one of the first measures of spread we can do is the interquartile range. You just take those two quartiles, Q3, Q1, you subtract them. And that kind of tells you how spread out the numbers are. If these are very far from each other, then the numbers are spread out. In this case, well, 2 minus 1 is 1, and so the interquartile range is 1. Another thing we can do is the standard deviation. Now this, rather than just picking out two numbers and subtracting them, the standard deviation includes all the numbers in the entire data set. And it's kind of a way of trying to roughly describe how far the numbers are from the average on average. There's some wrinkles on that. We're not going to go into the exact formula for it here, but fortunately, Excel is wonderful at calculating this sort of thing, so we can do this. If I want the standard deviation, I do STDEV. I give it the range of numbers, A2 through A6, and I find the standard deviation is 1.14. If those numbers were all the same, I don't know, if every person was issued their standard 2 pets, so the numbers were 2, 2, 2, 2, and 2, the standard deviation would be 0. If some of the numbers were really big, one person has 100 pets and another person has, I guess you can't get less than 0, then the standard deviation would be bigger. It measures how spread out the numbers are. Fantastic. All right, now one thing that we will often do is if I want to, again, I've got the weights of 300 cancer patients. I want to boil this down as much as I can. One thing I can do is give you a 5-number summary. That gives me a good sense of what the numbers look like, how spread out they are, how bunched up they are, where they exist. A 5-number in summary is the minimum number on the list, the first quartile, Q1, the median, the third quartile, and the maximum. Between those 5, we can get a pretty good sense of what we're talking about, of the household incomes of our customers or the mileages on these cars to see exactly how these numbers are scattered around. But even better than giving you numbers is to make a graph, to make a plot. I don't know about you, but I can understand graphs much more easily. You just glance at it and you can begin to get a feel for what's going on. So this kind of graph is called a box plot. Very cool. And it's a way of displaying the 5-number summary. A box plot tells you what the 5-number summary is. In this case, we have a box plot for the daily average temperatures in Madison, Wisconsin for November 1940. So we've got daily averages, probably about 30 different 30 numbers. And so what do we have? So here's how it works. The box extends from the first quartile to the third quartile. The median is a line right down the middle of the box. And then we've got these 2 lines sticking out the sides, which are whiskers, and they extend to the minimum and the maximum. So if I'm looking the daily average temperatures in Madison, Wisconsin for November 1940, apparently the hottest day was just about 55 degrees. The coldest day had an average temperature of 13 degrees because it's November, it's wintertime. The median looks like that to be about somewhere around 35 degrees. So that means half of the days in that month were hotter than 35 degrees, and half of the days in that month were cooler than 35 degrees. The third quartile right here was about 44, so 3/4 of the days were cooler than 44, 1/4 of the days were hotter than 44. There's the first quartile, about 23 degrees, so 1/4 of the days were cooler than 23. 3/4 of the days were hotter than 23. And so then half of all days are between the first and the third quartile. So half of all days had an average temperature between 23 degrees and 44 degrees. A lot of information in a box plot. Very quickly gives you a graph that shows you what's going on. Here's another type of graph that we will look at often, a histogram. A histogram is a special type of bar graph. On the horizontal, the x-axis of the bar graph, it tells you the range of the data. And then the vertical tells me how many things are in each of these ranges. So here, this data is the heights of black cherry trees as measured by a biologist. So a biologist went out, measured a whole bunch of black cherry trees to figure out how tall they were. And what do we find? Well, we find that looks like 3 trees had a height of between 60 and 65 feet. Another 3 trees had a height of between 65 and 70 feet. Looks like 8 trees had a height of between 70 and 75 feet. 10 trees had a height of between 75 and 80 feet, and then you can see how it works. Histograms are very useful things because, again, they tell you, without looking at all the individual numbers on this long list of numbers, you can see how things are distributed, and you can begin to describe what's going on. So there's our quick summary. We have looked at measures of center, mean, median, and mode, all 3 of which are kind of telling us something about where the middle of a data set is. Percentiles and quartiles. Measures of spread, that tells us how scattered out these numbers are. Are they all bunched up or they are very far from each other, the interquartile range and the standard deviation? We often put these together to make a 5-number summary, the minimum, the quartiles, the medium, and the maximum. And then we have ways of displaying the 5-number summary with a box plot, and we can also make a histogram as another way to describe our data set. So with these, we can do a pretty good job of describing just about any data set out there.